Problem number 42. In this question, we have to answer for three subdivisions, right? So let's read the question first and then we can give the answer one by one. So what is given in the question? Two trains are traveling towards each other at 35.7 meter per second relative to the ground. One train is blowing a whistle at 850 hertz. First question, what frequency is heard on the other train in still air? So let's we answer one by one. So first I'm going to solve the first part A. So let's we draw the diagram. By that it will be very easy. So there are two trains. So train 1 is here. And then another train is here. And these two trains are traveling towards each other. That means it will be moving in this direction and that will be moving in this direction. That means opposite to each other. And also they mention out of these two trains, one train is blowing a whistle. So whenever any object is going to emit the sound means we have to consider that as the source. So let's we consider this is the source. So this train is going to emit the frequency. So let's we take this is the source. Why I consider this the source? Because we mentioned one train is blowing the sound. So we consider this is the speed of the source and this is the speed of the detector. And what is the speed of the source? They clearly mention, which is 35.7 meter per second. And this is also 35.7 meter per second. And this train is going to emit the whistle. So we have to say the frequency emitted by the source, which is F, takes the value of 850 hertz. Now what we have to find? We have to find what is the frequency heard by the other train. Clear? So now we have to apply the rule. What's the rule? In theory, we studied the general formula for the Doppler effect. So the formula for the Doppler effect is given by F dash, which is equal to V plus or minus Vd over V plus or minus Vs multiplied by the frequency. Clear? And we have to consider the speed of the sound here is 343. So let's we consider the speed of the sound in the air, which is 343 meter per second. We have to consider. Now the most important thing here, if you want to get the answer for this question, part A, the most important thing, we have to be very careful about decide about the sign in the numerator as well as in the denominator. So what sign will come in the upper part, what sign will come in the lower part? That's very, very important. So for that, I can write the formula for A part, F dash, which is equal to V Vd over V Vs multiplied by F. So now let's we fill this gap, because the sign is an important thing, because that will decide your answer. So when this source will coming towards the detector, it will take the positive sign. When the source will be moving away from the detector, it will take the negative sign. So here, according to this diagram, so what diagram I mentioned here, you can see this is the source we consider, because it is emitting the sound. It is approaching the detector, right? It is going to approach the detector, so it will take the positive sign. If it is moving away from the detector, we have to put negative sign. So you should be very careful. And the most important thing, when the source is going to approach the detector, so the detector is going to hear the maximum frequency. So the denominator part plays an important role. If you want to get the highest value of the frequency, the denominator should be negative. If you want to get the lower frequency for the detector, then the denominator should be positive. So here, when the source will approaching the detector is going to hear the maximum frequency. So the denominator part should be smaller. So we have to fix the negative sign. So now what I'm going to do, I'm going to substitute the value here. So let's we substitute the value. So F dash, which is equal to V, the speed of the sounding air, we already mentioned it's a constant. So let's we take 343 meter per second plus what is the speed of the detector, because both detector and the source traveling at the same speed opposite to each other. So 35.7 0.7 over 343 minus 35.7. And what is the source frequency? The source frequency here is multiplied by 850. Let's see what is the answer. So for sure the answer should be greater than the source frequency. So here I got 343 plus 35.7 over 343 minus 35.7 multiplied by 850. Here I got the answer as f dash, that means the frequency hit by the another train. That means here the value here is f dash. I got the answer as 1047.5 hertz. So this is the answer for the first part. Now we have to answer for the second part. What is given in the second part? What frequency is heard on the other train if the wind is blowing at 35.7 meter per second towards the whistle? So let's draw the same diagram for part B. So and then I will explain. So first of all, let's draw the diagram. You have two trains. So train 1 and this is train 2. So what is happening here? Your source is traveling at a speed of 35.7 meter per second and detector it's 35.7 meter per second, and then the source frequency is 850 hertz. So this is our source, this is our detector. So both are moving towards. So now what they mention, let's go back to the question one more time. What is given? What frequency is heard on the other train if the wind is blowing at 35.7 meter per second towards the whistle and away from the listener? So you can see this is the detector. That's detector is nothing but the listener here, right? So now they mention now the wind is moving exactly opposite to the source speed. So that means I can draw the arrow mark one more time. So now which direction the wind is blowing? The wind is blowing in this direction. That means wind blowing direction is mentioned here, which is away from the listener. So that means when the wind is moving in this direction, what is the speed of the air? So this time we have to be very careful about deciding the speed of the air, because here this wind is against the source. So we have to write the speed, which is nothing but 343 minus the speed of the wind. Clear? So by that we have to write, because also they mentioned the wind speed is 35.7 meter per second. So 343 minus 35.7. Here I got the answer for B as 307.3 meter per second. So now what I have to do, I have to use this new value of the speed in the formula. What formula we framed in the earlier question? We got the formula in the previous question as f dash, which is equal to V plus Vd over V minus Vs multiplied by F. So this time what we have to do, in place of V we have to substitute this new value. Previous question we substitute 343. So why we substitute this new? Because they mentioned in the question the wind is blowing against the source. That means whistle is coming from the source. Clear? So what we have to do, we have to subtract this value. So for that we do this calculation. Now we have to substitute the new value of the V. So let's see what is the answer for this part. So 307.3 plus 35.7 over 307.3 minus 35.7 multiplied by 850. It's a source frequency. So here I got the answer. So this is our part B, right? So here I got the new answer. So f dash, which is equal to 1074.64 hertz. So let's see one more time whether the answer is right or wrong. 307.3 plus 35.7 over 307.3 minus 35.7 multiplied by 850. Yes. So 307 into 35.7. So here I got the answer as, let's see, so I can 1073.45 hertz. Clear. This is the answer for part B. Now we have to answer for part C. So let's see what is in part C. I have to go back to the question one more time. So what is given? What frequency? So what frequency is here when the wind direction is reversed? So it's very easy. We have to consider the second diagram. This is the second diagram, right? So the wind is moving opposite to the direction of the source. So we subtract, but this time what they mentioned, the wind direction is reversed. So reverse means we have to find the answer. So I can draw the diagram. This is train 1, we consider as a source. This is train 2, we consider as a detector. So the speed of the source here is 35.7. Now the wind direction, this is the wind's direction speed in this direction as 35.7 meter per second, and this is the speed of the detector, which is 35.7 meter per second, and the source, this is the detector, and source frequency is 850 hertz. So now we have to find the answer. So this time what we have to do, we have to again change the value of the speed of the air. So this time it is moving against the detector. So what we have to do, V, which is equal to 343 plus the speed of the wind direction. So 343 plus 35.7, this time I got 378.7 meter per second. Again I have to use the same relation, F dash, which is equal to V plus Vd over V minus Vs multiplied by F. So I have to substitute the new value of the speed of the air, which takes the value of 378.7 plus 35.7 over 378.7 minus 35.7 multiplied by 850. So let's see what is the answer now. 378.7 plus 35.7 over 378.7 minus 35.7 multiplied by 850. I got the answer here as F dash. That means the frequency hit by the detector is 1026.94 hertz. So this is the answer for part C. That's it. Thank you.